Make it, but with the shortened hours, we're just going to see where we're at. So inverse functions, our last section about functions. So today we're going to talk about how do you find the inverse? How do you know from the graph two functions are inverses? How you use compositions of functions to make inverses? Anything and everything to do with an inverse. So here we go. Now, graph those on your graphing calculator. So I'm going to give you a minute. Pull out your calculator. And then complete the table for the following. And notice, I picked the x coordinates just so we all have the same tables up here, so we're all matching. So let me give you a minute, type those in your graphing calculator and fill in the tables. You don't have to sketch graphs or anything like that. Okay, so what do you have? It looks like some of you already have them figured out. What do you have for your y coordinates on the first one? What do you have for this guy? Negative. What's your second? What do you have for 2? 5 and 8. Got it. Okay, then of course, hopefully you've already typed this one in. For -1, what did you get? 0. What did you get for 5? 2. And 23 gave you. Now again, I picked the specific x coordinates, so A, we all had the same t-charts, but also, what do you notice about the tables? And that's what makes them inverses. These two functions are inverses of each other. So one element of being an inverse is the t-chart switch. X becomes y, y becomes x. So that's an easy way I can tell from looking at tables if they're functions. If I have to make a graph of the inverse, I can just switch x and y. So that's really kind of the theme of today. Now the other thing I'm going to show you, I talked about it briefly when we did vertical line test way long ago. We're going to talk about one-to-one functions. One-to-one functions have to pass what we call the horizontal line test. And we're going to talk about what a one-to-one function is and why we need it, why it's important, and then we'll get into all the different inverse stuff. So functions, way back at the very beginning of the chapter. If each element of the domain is paired with exactly one element of the range, then it is a function. Well, this is kind of what we're going to take a look at. So the first figure is what we call a one-to-one function. The second is not. But, I will tell you this. The second, of course, is a function. They're both functions, but only the left is one-to-one. So first, let's just review why they are both functions. Each x, so 4 is paired to one number, 3 one number, 2 one number, 1 one number. Now if I put 1 to like 7, 1 would be cheating. It would be mashed up to 2 values. It would not be a function. But it is. 4 is with one number, 3 with one number, 2 with one number, 1 with one number. So they are both functions. But of course, this is a one-to-one function because notice you have 0 repeating in the y. So to be one-to-one, x can't repeat, y can't repeat. Here, you have 2 y values, really 4 and 4 for the 2 different values of your input here, your 3 and 2. Still a function, just not what we consider to be a one-to-one function. Basically, you can have no repetition. No x's can repeat, no y's can repeat. And why do we need one-to-one functions? Why is that important? Only one-to-one functions have inverses, which is what we're going to talk about today. So a function is one-to-one if no 2 elements in the domain have, of course, the same element in the range, the y's. So no repeating of x, no repeating of y. Now, of course, this little symbol here is the mathematical symbol for one-to-one. Because who wants to write out the words one-to-one? That gets obnoxious. So that's our little mathematical symbol. Now, we have used the vertical line test to test for function. We're going to use the horizontal line test, which is like the vertical, the horizontal, to test for one-to-one. That's our next mission. So functions one-to-one if and only if no horizontal line intersects the graph more than once. So it works the same way as your vertical line test does, but of course horizontal. So determine if the following functions are one-to-one. Now, you can, of course, get the t-chart and the graph and all that off your calculator. Sometimes it's easier to just kind of, quote-unquote, mental math a t-chart. If I put 0 in for x, 0 cubed, 0. So that would be a point. If I put 1 in for x, well, 1 cubed, 1. I'm going to put 2 in for x. What's 2 cubed? 8. So 2, 8. Okay, probably going to not put 3 in, because what's 3 cubed? 27, we have the graph. Okay, probably should throw some negatives in though. What's negative 1 cubed? And what's negative 2 cubed? Yeah. So you could get this, of course, like I said, off your calculator. Let me kind of draw this in here, a little cubic function. So determine if the following functions are one-to-one. Well, first off, I mean, it says in the directions it's a function, first off. It is a function, because it passes the vertical line test. Now, the question is it a one-to-one function? Will it pass the horizontal line test? If you draw a horizontal line anywhere on the graph, will it touch more than once? No, so we're good to go. One-to-one. I'm going to use the symbol. Okay, same thing. You could get the t-chart and the graph off your calculator. I'm going to mentally do it. Of course, x squared is a parabola. 0 squared, 0. 1 squared, 1. 2 squared, 4. I probably should put some negatives in. Negative 1 squared, 1. Negative 2 squared, 4. Well, first question. Is it a function? Yes, passes the vertical line test. Is it one-to-one? Heck no, because of course it would hit twice. So that is as wild and as crazy as the horizontal line test gets. Any questions about that? Now, of course, why is a one-to-one function important? Those are the functions that have inverses. Okay, so that's leading us to our next big talk of the day. So let f be a one-to-one function, then its inverse. And this is the notation. Looks like f to the negative 1 power, but that negative 1 is the inverse. That's the mathematical symbol for it, is defined by the following. So if you look at this notation, which means the notation looks crazy, f inverse of y equals x, f of x equals y. It's the exact same thing we did in the warm-up problems. It's just telling you the t-chart switches. X becomes y, y becomes x. So I'm just going to put a little note to kind of break down this little craziness. X and y switch. Which is why, always a why, always a reason here. I have the next thing on your notes here. To actually find the inverse, because we're going to find it next, I'm going to switch x and y. I'm just going to switch those two letters. I'm going to keep everything else the same. Then I'm going to solve it for y, so I'm back into my function form. And like it said, this little f to the negative 1 really means f inverse, that symbol. If you look on your graphing calculators on the, I'm going to picture it, left side, far left side, there's that x to the negative 1 key. It's really your inverse key on your calculator. Just a little FYI. All right, example 2. If f of 1 is 5, f of 3 is 7, f of 8 is 10, find f inverse of 5. Easy. Okay, f inverse of 5. What do you think? 1. They just switch. God, I love this problem. Okay, let's do, of course, f inverse then of 7 is 3. Let's just have a test on this, right? F inverse of negative 10 is 8. So the x and y's just switch locations. That's as wild as it gets. We're going to do the same thing, same concept. I swear I said like switch x and y a million times today, but off a graph. Same idea, same concept. A graph of the functions given, use it to find the values. Well, remember, f inverse, so they're giving you the y. So I need the x out of you, okay? So look at your graph. I'm like, okay, all right, got it. y2 would be right here, so I'm looking at this point. What's the x coordinate? 4, 5, 6. Got it. Okay, f inverse of 5. So again, 5 is y right here. So I need the x coordinate. 2. Got it? And what do you have for f inverse of 6? 0. We could do this all day. Any questions on that? All right, I think I've said switch x and y enough times here today. So here is where that goofy composition that we kind of practiced yesterday and the day before comes into play. Composition helps us with our inverse functions because it is one way you can verify that they are indeed inverses. You have to do f of g, g of f. You have to do both directions, of course, if they equal x. Not 5x and 5x, x. They have to equal x and x. They are, in fact, inverse functions of each other. So it is a way to, quote unquote, check your inverse, verify the two functions are actually inverses using compositions. So show that those are inverses of each other. All right, so we're going to do f of g, g of f, and they better equal x or something bad happened. All right, remember right into left, you're gonna put G into F. So I'm gonna replace x with x to the third, and then we have to raise that to the third power. Well, a little throwback to chapter 1, exponent properties, power to power. What do you do with the third and 3? So we end up with x to the first. I'm just gonna write x. Looking good, looking good. It's gotta work the other direction too. So F into G. F into G. So we're gonna replace x with x cubed. Then I have to raise it to the third. Real shocker, x. So since they both equal x, they are in fact inverse of each other. That's what they wanted us to show. That's what we did. We crushed it, we got it. If you equal anything besides x and x, they're not inverses. Has to be plain old boring x. Okay, the last big thing we're gonna do here today is actually find the inverse. So if I like give you the original function, how do you make the inverse of it, of course? So, as always, we are going to, here I go, saying it for the 50th time, we're gonna switch x and y, theme of the day, and then of course we're gonna solve for y. We're gonna put it back in a y equals format. That's as wild as it gets. So here we go. Now, if you don't like f of x in there, the function notation, remember, I know you know this, I'm just for dramatic emphasis gonna rewrite it as y. So still my original function there. Now to get the inverse, I'm gonna switch x and y. So x equals 3y. Everything else stays the same, notice. And then I just solve for y. So I'm gonna add 2 and divide by 3. Now, I don't care if you split this up and put it 1/3 x plus 2/3. If you leave it, it doesn't matter. But for my final answer, I'm going to write it pretty. I'm going to say, okay, F inverse. I'm going to split it up. I'm going to make it 1/3 x plus 2/3. That is as challenging as it gets to make the inverse. We got it. So same thing, up to you if you want to first rewrite that f of x in a y equals format. You probably could skip that step, but of course then to find my inverse or make the inverse, I switch x and y. So x equals y to the 5th. That's the only thing you change is x and y. Everything else stays in the equation. And now I'm just going to solve it. Let's get rid of this fraction, times each side by 2. I'm going to add the 3 over. And what gets rid of a 5th power? 5th root. And then all I'm going to do is write my final answer nice and pretty. I'm going to say f inverse is the 5th root of 2x plus 3. And I'm running out of room. Got it. Got it snuck in there. Any questions on that? All right, one last one of these guys. So again, same deal. I think we're past having to rewrite it y equals. Let's just switch x and y. So x equals to y. Okay, and of course we want to solve for y. So let's go ahead and of course, let's maybe eraser. Let me put a y in for that one too. I can't write and talk. Okay, so same deal. I would probably go through and of course clear out your lovely fraction. So let's do the y minus 1. Take a look at where we're at over here. So remember, we want to solve for y as our goal here. You can distribute this. I'm going to go ahead and distribute xy minus x. Now this one's a little spicy. Hi, Landon. A little spicy because we have so many variables everywhere. Remember the goal. This is a throwback to chapter 1. That's the only reason I threw this one in here. I would get the y's on the same side and put all the other junk on the other side. So it doesn't matter how we move it. I'm going to subtract xy over to the right, and I'm going to subtract 3 over to the left. So I'm going to subtract xy and put it on this side. I'm going to minus 3. So let's see what we've got. I've got negative x minus 3 on the left, 2y minus xy. It's the only reason I threw this one on, just to throw back to chapter 1. Now, a little spicy, on the right-hand side, what do you notice both terms have? So I'm going to factor. So I get to review factoring. I'm going to factor a y out. I'm going to have 2 minus x left. And then, of course, to solve for y, I'm just going to divide off 2 minus x. Such a great problem. Okay, let's write it pretty, of course. F inverse. Let me fill in this fraction. Negative x minus 3, 2 minus x. Man, that was a great one. Now, this is one, clearly took a little bit more work to solve. But let's say you're like on a test and you're like, oh man, I just don't know if that's right. And we're going to screw up my algebra. Well, quick, easy way to check it. Graph the original function, like the warm-up problem, and graph your inverse and make sure the tables are flipped. That would be a quick, easy way to double check that you do in fact have the right equation here. Just throwing that out there as a little pro tip for you. Okay, so let's talk about the graphs, shall we? Let's talk about the graph. So I wish we had color copy machines because mine are so pretty to color, yours are not. So one thing about the graphs, because we're going to start looking at the graphs. If you just give me the picture of the graph, no equations whatsoever, no t-charts, nothing, just the graph, I can look at the graph, you should be able to look at the graph and tell if they're inverses. So A and B, of course, switch spots to be A, they just switch the ordered pairs. Here they're fancy using A and B instead of X and Y. But again, I'm going to say it again, you're switching X and Y, of course. Well, how that results on the graph, so Y equals X, of course, our identity function is what it's called. Notice if you fold the two different graphs, the F and the blue and the red, if you flip them over my yellow line here, they match up. So they're symmetric over the line Y equals X. So I can look at the graph and tell you whether or not it's an inverse just from the picture. So that's what we're going to do next. Sketch the graph. Okay. Now I'm going to do it by hand. You can do it in your calculator. You know, I'm just going to make a t-chart. And now we can review domains for fun. What type of numbers can you never square root? So what's the first number I'm going to start in my t-chart with? 2. Because you would do x minus 2 is greater than or equal to 0. All right, 2 minus 2 is 0, square root of 0. Got it. Let's put 3 in. 3 minus 2, 1, square root of 1. Now I could put 4 in, that's fine. I could put 5 in, fine. I'm going to actually go to 6 because of my lack of drawing skills. Here's the only reason why. What's 6 minus 2? 4, and the square root of 4 comes out nice because we all know I can't draw. You could use 4 or 5, it doesn't matter, you'll just get a decimal. Okay. Got it. Then use the graph to sketch the graph of F inverse. Okay, and get an equation. Well, all right, let's make F inverse. Now, I think I can get you the graph pretty easily for F inverse. Because what am I going to do with the t-chart? Flip it. So I'm going to plot 0, 2, 1, 3, 2, 6. And let's take a look at it. 0, 2, 1, 3, 2, 6. Okay. Now, just for dramatic emphasis, I might regret using yellow. We'll see how well this shows up. I can tell you, if you gave me no other info, that those are going to be inverses. Because if you mark out that y equals x line, which again, I might be regretting this yellow, I can see if I fold it over the yellow line, they'll match up. It's symmetric over that y equals x line. Now, let's get to this part. They want the equation of the inverse. Well, choices, how you do it. I could go old school like we were doing. Switch x and y, solve for y. Totally can do it. And I might do that too. Or I recognize this is half of a parabola. So think about your parent function parabola. Our parent function usually starts down here at 0, 0. We're starting at 0, 2. So my function, my inverse function, I'm just going to use g to use a different variable, is my parent function shift up 2. But that would be for the entire parabola. I only have the right side. So I'm going to semicolon. So I only have the right side, meaning I only have the side on the right of 0 for x. Now if you're like, man, I would never look at that graph and be like, that's half of a parabola, it's shifted up to, and do all of that stuff, you can still do your switch x and y. X equals, and then solve for y. And lo and behold, we get the same thing, x squared plus 2. Look at that. But realize you only have half of it, the right half, the positive half, so I wouldn't have the plus or minus. We would just have to put on our x is greater than 0 now. Got it. So I don't care how you do the equation, as long as you can get that x squared plus 2, I'm happy with you, as always. All right. Why not do a word problem? Now, I know how we feel about word problems. I promise you this one isn't too bad. At a local pizza parlor, the daily special is $12 for plain cheese pizza plus $2 for each additional topping. Write a function f that models the price of the pizza with n toppings. And we'll get to b in a minute. Okay, so find a function f. They're using n for a variable that models it. Well, piece of cake, your plain basic $12 for the cheese. And I don't know, I'm going to add $2 for each topping. Now, personally, I don't care if you leave it. That just bothers me. I like the variable first. That's how I roll. I'm going to make it 2n plus 12. Okay. Find the inverse of the function. What does it mean? Okay, let's do the inverse. So, of course, we're going to switch x and y, of course. So, in this place, we have n. If you want, of course, you could rewrite this. If you like the x and y, because they got fancy and switched variables, who cares? Now, of course, I'm going to switch x and y. So, x equals. And I'm going to solve for y. So, I'm going to take the 12 off. I'm going to divide by 2. Now, just because we're in this word problem, I'm going to put it back instead of x. I'm going to put n for it. So I'm going to say f inverse of n. I'm going to make it half n, or you can leave it n over 2, I guess. I don't really care. Half n, and then 12 over 2 6. That's kind of a messy n we got. Okay, and what does f inverse, of course, represent? Our next question. That, of course, because n is our number of toppings, so number of toppings for a pizza. I'm getting hungry for pizza. Go get it, Max. We'll see you soon down there. It's going to be awesome. Okay, if a pizza costs $22, how many toppings does it have? Anybody? Can you mental math it? 5. Okay. So if the pizza costs $22, put your 22 in here. We're going to solve for the toppings, and just like that, Max is that. All right. Solve it. Subtract. You got 10 equals 2n. N equals 5. I'm going to put 5 toppings. Or, that's one way to solve it. For fun, because there's always more than one way to do it, how else could we get the 5 toppings? Well, put it in the inverse here. So remember, we switched up our variables. So you could have put 22 in there, half of 22, 11, 11 minus 6, 5. You get the same thing. I don't care how you do it, as long as you get your 5 toppings. Piece of cake. All right, home stretch here. One-to-one functions given. Use your graphing calculator for part B. Okay, all right. Find the inverse of the function. Well, I know, you're shocked. I'm going to say it again. We're going to switch x and y. So let's put y equals, or x equals, sorry. I'm not going to rewrite it y equals style. We're past that. We can handle it. I'm going to subtract 1. I'm going to get rid of squaring with a square root. Now, this is the only little spicy part of this problem. What needs to go in front of that square root? Okay, all right, that makes me nervous. Here's why that makes me nervous. And we're going to have to adjust it a little bit. Would this equation be even just a function? Does it pass the, hey, you put one number in, you get one number out test? No, it wasn't. So we're going to have to adjust it because I see this little fun little note up here. They're only looking at half of the parabola, so I'm pretty sure I'm only using either the plus or the minus. Because if we were to graph this in our calculator, which I'm going to show you, this is kind of a rough sketch. It would be a sideways parabola, which clearly doesn't pass the vertical line test. So I am going to adjust that. I am going to finish that. But let's get the graphs up here and take a look at them. So I'm going to do the original one first, which we all should probably know that's a parabola by now, x squared. I can probably get rid of this. X squared plus 1. Now, they are looking, of course, at the right side of the parabola. X is greater than or equal to 0. So ignore the left. I'm only looking at that right-hand side. So I'm thinking about, okay, all right, what do we think gut instinct? Are we using the plus or the minus? Plus, because they're looking at the right side. So just to verify it, so I'm going to put in, enter, I'm going to put, come on, board. How many times must I cross it? Okay, so I'm just going to use the positive. I'm not going to put the negative in. Square root x minus 1. Hit a graph. Now remember, ignore the left side of my parabola. Mentally picture it. If I ignore this left side I'm trying to cover up with a blue parabola, are they symmetric over that y equals x line? They are. So, I'm going to back this up here. I'm going to erase some room. I'm going to pull a graph up here so I got some room to write. Let's go back to it. And I'm going to put my inverse equation, F inverse. And I'm just going to, I am not writing this messy, I promise. And over here, come on board, the positive. And then, did we already do part B? Yeah, we got it. Now, quick question for you, and Lily, I'm going to answer yours in a minute. What if this said instead of greater than or equal to 0, what if that was less than or equal to 0? What would change here? You'd use the negative one. You'd use the left side of it. Lily? I don't, because of the fact I use the positive here in the front. So that's how I can ignore that or not have to deal with that. All right, last thing of the day. The given function's not 1-to-1. Why is it not 1-to-1? What test is it failing? Okay, all right, you guys are good. Restrict its domain so the resulting function is 1-to-1. Find the inverse with the restricted domain. There is more than one correct answer. So here's the deal. To get this to pass the horizontal line test, we get to pick. That's why it says there's more than one correct answer. I'm either going to use the left half or the right half of the parabola. What do you want to use? Right, okay. So we're going to focus on this one. So that means I'm going to add a little note there. I only want the parabola on the right side of 1. Semicolon. Okay. So that was the first part. Restrict the domain so the function's 1-to-1. I did it. I did that. Okay. Now it says, of course, find the inverse. Switch x and y. Solve for y. And we're probably going to have to make an adjustment here on this too. Square root, square root. We should have plus or minus. We'll deal with the plus or minus in a minute. I'm going to add the 1 over. Now, before, of course, I might make my pretty F inverse equals, we got to be smart here. Are you using the plus square root or the negative square root? Plus, since we went on the right side here. So for my inverse, I'm going to keep the positive square root. I'm not going to put the positive, so I'm just going to put square root of x. Now, the reason it says there's more than one correct answer, what if you used the left side? What would change here? You'd put the negative in front of the square root. You would select that one. So that's why there's more than one choice, depending what half of your parabola you chose. Any questions on that? All right, you crushed it, kids. Let's grab your homework here. Hope you guys don't have too much homework this weekend with homecoming. Well, we can get this done at lunch or something.